Okay, so my name is Rebecca Bussard. I am entering my third year as a PhD candidate at University of Oregon. Crazy. And today I will be talking to you guys about tools for improving the accessibility of Insar. So just a brief outline of this talk. I'll first go into what is Insar, then talk about using Insar a little bit, and then improving the accessibility of Insar is kind of what I did in this internship. I'll end with a conclusion and my acknowledgements. So I've tricked all of you into coming to basically an Insar talk where I get to talk about my favorite method. Insar stands for Interferometric Synthetic Aperture Radar, and it is quite a mouthful. So I'm going to go through each of the words, and I've actually found it most useful to do it backwards to give everyone just a brief info if you're not familiar with Insar. So the first aspect is radar. So whether you're using a spaceborne or an airborne satellite, they emit radar waves that essentially go down, travel through the atmosphere, hit the ground, scatter off the ground, and return to the satellite with both phase and amplitude information. So that is the radar aspect. And then for the synthetic aperture, essentially the way that the satellites work, if you have a longer antenna, you can image more narrower areas, so you can have a better spatial resolution. And the length of antenna we would need to get the resolution that we want is too large to create or build. So using geometry and kind of a trick of geometry, we can essentially create a synthetic aperture, the way that the satellites image the Earth. It kind of produces this synthetic long antenna that gives us resolutions down to millimeters and centimeters of the Earth's movement that we can track. And then lastly, the interferometric. So as I talked about before with the radar waves that come back to the satellites, you get both the phase and the amplitude information. And for Insar, we are particularly interested in the phase information because when you subtract phase information from one date from another, you can get a phase interferogram, which tells you how the ground has shifted between those two dates. So a much prettier interferogram in my opinion. This was done with Sentinel, and essentially it was between September 6, 2018 and September 18, 2018. And if anyone can guess what this is of, you win my presentation. But this is essentially what I get to make for my research and also what these interferograms look like. So using Insar, the benefits of Insar is that you can image Earth's surface at any time of day or really during any type of weather, which is a bit better than optical data where you usually have to have it during the day. And if there's clouds, that can be an inconvenience. It typically has better spatial resolution than other geodetic methods, and it can be done remotely. So particularly in my type of work, I use Insar on volcanoes. So that can be a lot safer than going out into the field if they're erupting. The weaknesses of Insar is that you can only measure ground movement currently in the vertical and east-west directions. And I say currently because there are a bunch of really smart and talented people figuring out how to kind of get around that right now. But general Insar, those are the main two that you can measure right now. It does not have amazing temporal resolution compared to other continuous methods like GNSS, which is why you typically see Insar and GNSS paired together, because Insar does have quite robust spatial resolution and GNSS monitors things consistently instead of Insar, which has satellites image the same area between a period of anywhere from every 12 to every 35 days. And the last kind of weakness of Insar is that understanding and utilizing Insar can be difficult for first-time users. It is very, you do have to have a pretty decent computer science background right now to use it. So the first two weaknesses, you really need to solve them using kind of more advanced software or a fleet of satellites, and a lot of money I do not have. But the third one I can work on, and I can try to change that and essentially make things easier for people to use Insar as well as understand it. So kind of what I've been doing this summer is I've been trying to improve the accessibility of Insar. And there's kind of been three different ways that I've broken this down to. Making SAR data easier to access, making SAR data easier to process, and making educational tools about INSAR easier to locate and understand. So for the first one, it kind of got mentioned earlier in Courtney and Lucia's talk, but UNAPCO houses a tool called the Seamless SAR Archive, or SARA, that you can download SAR data from for multiple satellites. And what I did over the summer was I created 2 video tutorials that are now on UNAPCO's YouTube page explaining how to use both the SARA online GUI as well as the API. And the API tutorial also goes into how to download it from the GitHub and like set up your username and password if anyone is interested in that. I also raised a few issues in the GitHub for SARA, just kind of changing a few aspects of the code to make it run a little bit better. So that was the improving data access. Also making SAR data easier to process. So I also had a good time with Jupyter Notebooks this summer, and I've created multiple Jupyter Notebooks to run various scripts for one open source software. I chose the Insar Scientific Computing Environment. It's also known as the ICE software. It is one of the more commonly used, and like I said, it is open source, so anyone can use it. And the benefit of these Jupyter Notebooks is that they combine running the code with kind of explanations of each step that you're doing. So I've created these for pairwise INSAR processing, and I'm also going to be making ones that are for stack processing, since both are kind of helpful. And these are just some of the results that I thought would be interesting to show from my notebooks. So the image on the left is just a interferogram made with a pair of dates from 2010 over Guatemala City, but you can run the notebook with any data that you want as long as you specify which data you want. And then this is just a DEM that I downloaded with one of the notebooks that I made for ICE. Lastly, for making educational tools easier to locate and understand, each year UNAPCO hosts short courses on how to process INSAR with different software. I went through and organized over 40 hours of previously recorded short course material and essentially chopped them up into shorter, more specific videos. That way you could just find whatever topic you were interested in and you didn't have to go hunt through 7-hour long videos. And I will also be involved later on in the summer with the 2021 Insar Theory and Processing short course with ICE, ARIA, and MintPy tools. So if anyone's at that, you'll see me around there. And just to kind of conclude, INSAR is a geodetic technique capable of measuring ground deformation over large areas with high spatial resolution. And over the summer, I had the chance to create and organize many educational tools for using and understanding INSAR. And kind of the main reason that at least I find it's important to make INSAR more accessible is that INSAR is a relatively new technique. It first kind of came around in the 90s, but it already has numerous applications from solid earth to hydrology, glaciology. And because of its computer science aspect, it really fits into this kind of like big data and machine learning topics that are becoming really big. And then also in a much more just general sense, with more people capable of using INSAR as well as understanding it, you can have more areas around the earth being imaged and monitored for hazards. And the two pictures on the right are kind of illustrations of both of my points. So if you look at the top image, this was the cover of one of the more recent issues of Science, where they were talking about the radar revolution and how they're having these fleets of satellites, particularly with the US-ISRO NISAR satellite being launched soon. And then the bottom right picture is one of my favorites. This past May, a volcano in the Democratic Republic of Congo, known as Nyiragongo, erupted. And within the first couple of days, there were already people kind of imaging it with INSAR and sharing it on Twitter and trying to explain it. And this is kind of something that I think is really cool, is that you can have people image these areas very quickly and also try to share the information for the purpose of kind of hazards while that's going on. So just some acknowledgements. I would like to thank my mentor, Chris Crosby, for his help over the summer, as well as Matt Beckley and Scott Johnson for their assistance. I'd like to thank UNAVCO, NSF, and in particular, Anika and Kelsey for their help and support throughout the summer. And I would also like to acknowledge that the work that other people have done for resources using Insar, particularly the ICE and GMT-SAR groups that host short courses a lot through UNAVCO, and have also done a large amount to try to get this technique more widely used. So that, I will take any questions.
Excellent job. And like before, you can raise your hand and unmute yourself, or you can type your question into the chat. Ooh, Philip has a question. He says, is Insar processing in Jupyter similar to that of other toolboxes like, why don't you say, it looks like Giant and ISCE. Can you compare them?
Yeah, so whoa, I can't find my mouse. So the Jupyter notebooks that I made involve using scripts from ICE. So essentially it's kind of a different way to use ICE, but it has a bit more description than just kind of the commands itself that gives them. So that's the notebooks that at least I do.
I have a question. I'm just checking the chat. Okay. So do all this work. It's super impressive. I learned a lot from your talk, so thank you. If you were doing this over again, we rewound the clock and we're back in May, would you do anything differently as you like set forth on your project?
I would maybe try to, in the notebooks, kind of implement a bit more of how Insar can be very complementary to other geodetic techniques, especially like, as I mentioned, GNSS, and trying to include a bit more of that in there, just because it is a very useful technique to pair with other data sources and things like that. So I might try to include that a bit more in like just the educational material or the notebooks.
Okay, that's great. Let's see. Glenn says, lots of new notebooks. Will we gather and curate all of these on our website? Do you know?
That might be a better question for Chris. We haven't figured out exactly where we're going to put these notebooks yet, but they will go up at some point with advertisement eventually.
Yeah, a lot of the work that Becca did was really motivated by the WinSAR community, right? So I have to talk to the WinSAR about whether they want these to live inside of sort of a more WinSAR-centric kind of space or inside the UNAVCO broader GitLab or something like that. So open to suggestions, probably a conversation to have across GDS and with EC about where to best host all this kind of new content.